questions. All right, where are the metals found on the periodic table? Where are the metals found? Sierra, can you tell me? Just generically. Yeah, where are the metals found? I'm looking for answers like left, right, or on the stairs. Okay. What if I do this? Okay. The green is the stairs, right? If I write left, I write the words right. Where are the metals found? Are they on the left or are they on the right? Since I find students don't know their left from their right. Are metals on the left or are they on the right? Based on what we colored when we did the lab yesterday. What color were the metals? Were they blue or were they orange and yellow? Remember the lab we did? You turned in? Looked like this? Were the metals blue or were they orange and yellow? Yellow. Blue. Alright, so if they were blue, what side are they on? The left or the right? On the left. Metals are on the left. Where are non-metals? They're on the right. Okay, metals are on the left, non-metals are on the right. Questions? Alright, we're going to play a short Kahoot and try to review a little more because you have a quiz on this. And some of us, y'all are going to make me suicidal by the time I grade this thing tomorrow. Alright, somebody come get my key so you can open up the cards. We'll make Charisma and Zai because I'm not changing that computer list for 2.5 more weeks. So y'all get like computer 23 and 24 out of the cart.
What you got loose?
Miss what?
Yep. What? What about what?
When do we have our last bench?
You already took your last bench. Yes.
No, the final exam.
Oh, the final exam, the week of the 10th through the 14th. The 10th is like, well, it's actually the 10th through the 18th. The 10th and the 11th are teacher-made tests, and then the 14th through the 18th are the NCFE and the vocab.
I only got 2 tests.
Yeah. Great.
You look like water.
Thank you. I'm a bag of flesh.
You're doing Kahoot or
I don't know.
that's why
No, I just know every back. Somebody broke their backspace.
Oh,
Yeah.
freeze!
Huh?
Somebody took it.
What? Oh. You just fell off.
I found out that part.
The computer.
Shooter 15, no 13.
I'll do a check out.
Who's it led?
I called you.
No, it's this morning. She was great. She was great.
Pardon the interruption. At this time, there is a code yellow. No students should be out walking through the hallway. Please keep your students in class and continue teaching as usual.
No, it's just scary. Please. Just like book reading or something. Just talking about the color and they talk about no, they're trying to be crips.
Alright, are we in?
Stop playing, bro.
Missing 3.
Oh, shoot. Good luck. Don't leave me yet.
Hurry up. It only has 15 questions. It should be pretty short. It's just to review the parts.
4, 5, 3. Oh, man. This whole got me stressed out. There you go. Let's do this. I'm ready. Hey, I'm there.
Why do we have 2 Caleb's?
3 actually. But I'm the OG.
And that one needs to go. And that one needs to go. If you're the OG.
The original. Stop. Okay, I'm ready to go now.
Alright, Janai, that's who we were waiting on. Roy's in. I don't know who the other 2 were. Numbers on the board. You need a periodic table if you don't have one in front of you. You may use your color-coded one.
Welcome to Silicon.
Guys, this whole thing is about the periodic table. Why would you not have one? All 15 questions are about the periodic table. I would even recommend you use your colored one. Now, can you use your colored one on the quiz tomorrow? No. Colored one is notes.
I'm in second.
Now, where are your group numbers?
On the top.
They're at the top. This is group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Silicon's in group 14. I could have. That's not the point of the game. All right. What's the name of the group that's colored?
That's the easiest one, but no, all of them.
Nice. Should have been 100. Noble gases is the correct answer. There's another picture. This is why I didn't explain the last one.
This how the test gonna be.
No.
Oh, I got this.
I don't have a lot of pictures. But I might say, instead of drawing the picture, what's the name of groups 3 through 12? Or in the last one, what's the name of group 18?
It'll be multiple.
No, it's all for response.
What if you don't know how to spell it?
If you don't know how to spell it, you need to be close. All right. Now, I don't know what to say. The last question showed you the noble gases, and 2 people picked the noble gases for this one. Okay? The noble gases are where? These are the noble gases, right here, which is the last question. This in the middle is the what? Transition metals, which is what this question is asking. So I don't know if you're just guessing or you're hitting the wrong button because you're touching the wrong thing. What period is calcium in? Number 20 is the atomic number, make it easier for you to find it. Number 20 is the atomic number.
Here's on the right side of
Oh, that's so hard.
We'll talk about it in a minute if you don't mind. All right. Periods are left to right. So this is period 1, hydrogen, helium. Lithium to neon is period 2. Sodium to argon is period 3. So that puts calcium in period 4. Those of you who said 2, pick the group. Which one's a liquid? All right, it's not terrible, I suppose. All right, bromine is a liquid. What's the other liquid? Mercury. Iodine's a solid. Iodine is iodine. It's a solid.
Oh, yes. That's all right.
All right, there are the halogens. The boron family is group 13, and the carbon family is group 14. Which of the following is a non-metal? Now, where are the non-metals at? We're going to talk about this again today. What are the green? What are the green on the staircase? What's the green on the staircase? Jacob? What's the green on the staircase? William, get off the phone or I'm going to have it. William, you hear me?
Yeah, you're right.
Metalloid.
They're metalloids. So what is all this blue?
Metals.
All this blue right here are the what? Metals. This yellow and orange are the what? This yellow and orange are the what? Guys, these are the easiest questions to get right on the state test. Particularly for you guys who made the 30s and the 40s on the benchmark. Okay? We had everything from a 95 to a 22 in this class. Okay? We had a whole bunch of 30s and 40s in here. Those of you who made the 30s and 40s made it because you can't solve a math problem. The chemistry section can be what saves your behind. Blue are metals. Yellow and orange are non-metals. It's not hard to get those kind of questions right on the exam. Doesn't require you to be able to solve a math problem. Okay? But it does require you to pay attention at least between now and exam time. But like I told Mr. East, you just job security if you don't. Or Mr. Miller needs a job in Apex. Just saying. Or we could use Miss Wicker's line. Y'all are just working on another 90 days in a science class. Because this is not multiple choice tomorrow. Alexis, do you want me to have your phone? Now, Raul asked, will you have to be able to spell these tomorrow? The answer is yes. Now, if you have a vowel or a consonant wrong, I'm going to be okay with that. But if all you had right was the A and the word metal, would I be okay with that? No. Okay, it's got to be close. All right, so based on what we just talked about, which one's a metal? The numbers are the atomic numbers to help you find them. So which one would be a metal?
That's not.
Really?
It said one, but it's sodium right there, so it's hard to tell.
I clicked the wrong thing.
I don't even know what to say. Carbon is over here on the far side of the periodic table. This side is a non-metal.
No, I like clicked it on accident. Like I meant to click it.
Now what happened to the rest of the room? Only 4 people got that right.
I went to garage.
This we're going to spend more time with today. We wrote it down on our table yesterday. This is the only question I can be forgiving on. And we did better on that than the metals. We're going to review it here shortly. So I'm just going to skip it for right now. This better be 100.
Didn't I already ask this question?
In a different way. That's why I said it should be 100. Asked it in a different way. And 3 people got it wrong. I'm not even going to respond to it. I would like to think we're all going to get it right as many times as I've said they're at, but I'm losing faith.
No, I would cry if I got that wrong.
Where are the metalloids at?
On the staircase.
Staircase.
Yes, on the staircase.
TE is on the staircase though.
All right, now, aluminum is below the stairs, and which two did we say were below the stairs? It would be green. GE and TB. So aluminum is not going to be there. And PO, like I said, some periodic tables label it different ways. This one labels PO as one and AT not as one. We labeled it the other way. Why some books say it is and some books say it isn't, I have no idea. I can look in 4 different books and get 4 different answers. So I don't have any explanation for that one. We label TE as one, so technically that would also be correct. So I should have 2 right answers there. That one's my error. I didn't mean to put TE in there. Which one's a lanthanide? This one should be 102. Is it going to be worse? All right, find the period.
That one for this. I put the wrong one on
Okay. Because you moved your finger on
Yes, I'll try to make it off for
it? Okay.
At this time, this is a lockdown. This is a lockdown.
All right, somebody get the lights. The door should already be locked. Back there. Back there along the cabinet on the floor. Go. You're going to have to sit down. Along the cabinet on the floor. All right, well, you're going to have to sit down. All the cabinets on the floor.
Okay.
All the way through on the floor. Look, come back here. Just double check. I got to go through a check record first. From the outside.
We are now off of lockdown, but we will remain in a code yellow. We are now off of lockdown, but will remain in a code yellow. Reminder, code yellow. Yellow means no student should be released from their class without permission.
John.
What?
Have it?
All right, somebody can get the lights for us. All right, did we put answers in? All right, so, and I don't know if everybody answered before time ran out. So, if we look at it, not too bad. All right, periods again run which way? Across, and we're still on the code yellow, so you still can't go anywhere. That's period 2, period 3, and iron's here, so that's period 4. All right, I think we have one more. All right, which one of those is a gas? Now, at least less if you pick carbon this time, which is at least good. All right. Chlorine is a gas. Sulfur is actually a yellow solid. All right. So that's not the right answer, but chlorine is the gas. All right. Now, if you will put your laptops back in the cabinet, make sure they're A in the right order and B plugged in. And then put your butts back in the chair. Huh? Yep. We got several to do today.
I did the same thing you did.
I had more you bet. Oh, yeah. I am playing.
You may dismiss only the students that are going to lunch. The students that have second lunch may go to second lunch. Other than that, those students that do not need to remain in their classrooms and continue working.
The handheld one from a Simone.
Well, this one's a square 15.
All right, we got to put up.
Yeah, that's right.
All right, so some of the stuff that's in our slides today, you do not need to write down, okay? Unless you're somebody who just doesn't know the answers, and then you might need to write them down, okay? Several things that I have in here are just for review. You're going to need handheld one that Alexa is using because I don't have the mechanical one. It died. Now, sorry, I did. Which way do groups run? In a vertical column. Which way do periods run? Which way do periods run? They're horizontal. So let's say that I ask you about arsenic, which is this element right here on the quiz tomorrow. Let's just say arbitrarily that's the element I give you. And I say, tell me its group on the quiz. Can you tell me its group? All right, William cannot answer again today. All right, because I suspect he's going to know almost every answer I ask.
My turn to start answering.
All right. Can you find me the group? Arsenic, the one that has the red in it right there.
15.
All right. How'd you get it, Nathaniel? All right. You're looking on your note paper. You can't have that paper tomorrow on the quiz. So how are you going to find it tomorrow on the quiz? You count each group. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's how we put those numbers in yesterday. All right. How do we find the periods? 1, 2, 3, 4, 5, 6, 7. So it's in period what? 4. Everybody see how we did that?
Yep.
All right. So if I ask about platinum, which is here, what group is it in? And what period?
6.
Now, how do these two rows work? The lanthanide and the actinide? 6 and 7. Everybody remember that?
Yep.
Okay. Now, if I ask you by name, again, I'm not necessarily going to require spelling, but let's just say that I ask you to spell group 17.
HALOG.
They're the name of the headlights. Logan, do you hear me talking? Then who shouldn't be talking? That's okay. He can have his notes right now. How many times have I said that? Surely he's heard me. All right. Now, if all you have is the H, I'm not going to take it. All right. You have to be able to come pretty close, but maybe you've heard the name halogen headlights. That's one of the reasons we use it. It has an element from there in the headlights. I can't remember which one off the top of my head. All right. Now, most of them are not that difficult to spell. The lanthanides and the actinides are probably the hardest to spell for most students. Now, if all you have is LA or AC and then a disaster area, I'll be honest, I will mark it wrong, okay? And I get that a lot. And then people get their quiz papers back and they're mad because they're like, I knew what those were. Well, if all you can give me is LA, you're wrong, okay? Now, some of you might need to write this part down. Draw a basic sketch of the periodic table. You don't have to draw all that. Here. Here's a basic sketch because some of y'all will look at that and it'll take you 20 minutes to draw. Draw a column. Draw a box, a rectangle. Draw a rectangle. There you go. Can you draw that? Half of y'all can't do this. You can't tell me where the elements are on the periodic table, and you're not going to be able to tell me the properties I'm getting ready to ask you in a second. Draw a rectangle. Draw a shorter rectangle. Are you with me on 2 rectangles?
Yes.
Draw a small square. Those are your transition metals.
The stairs.
Draw a big square. Draw a rectangle. Now, I'm going to put stairs in. Now, the stairs don't necessarily have to be exactly what it has on the periodic table. We're just looking for something that's approximately correct, because we need to talk about the 3 sections on the periodic table, which is where we're struggling. Okay? Some of us cannot remember what's on what side, and we need to talk about the properties of the elements on the periodic table. Now, you should have done this in middle school, but I've learned that's probably not what you remember. So, what are the 3 types of elements on the periodic table that you colored the other day?
Gases.
No. A lot of y'all wrote gases, and I marked those answers wrong. What? Metals will work? Okay, where are the metals at? They're on the left of the staircase. So metals are here and here. Okay, so metals are on the left of the staircase. Okay, metals are on the left of the staircase. What else do we have? Metalloids are where? All right. I'm going to write them this way. Okay.
And then we have non-metals.
Okay, metalloids are on the staircase.
Non-metals are to the right.
And then we're going to put non-metals over there. And on Friday, we're going to talk about bonding. And this is all going to be important when we put bonding in here. Non-metals are on the right of the staircase. Because you can't start to tell me about bond type if you can't remember where the metals are and where the non-metals are. When we start talking about bonding, it will not matter to me at all about the metalloids. I won't care. But you're going to have to be able to tell me about metals and non-metals. Metals are on the left. Non-metals are on the right. Okay? Everybody with me on that? All right. Now, we need to talk about some properties of metals, non-metals, and metalloids. Something maybe you remember from maybe earlier this semester that we talked about, or maybe something you remember from another science class. I don't care. Okay? There are basically 4 properties I'm hunting for that are characteristics of all metals. Does everybody have what they want? That's not what I want. I will tell you that I took any of these 3 answers, though, on your periodic table lab that you turned in. I can't remember. I think it was question 10. So how's the periodic table arranged? I took any of those 3 answers. Okay? Most of you told me this. Most of you told me by atomic number. Some of you told me metals, non-metals, and metalloids, which I did take. And a few of you told me outer shell electrons. I took all 3 of those answers because I did not care. All right, this is where we're going with it. Tell me something you know about a metal.
Solid.
Are all of them solids?
Yes.
Not all of them.
Which one's not? There are 2 liquids on the periodic table. What are they? Mercury and one of them is a metal. Mercury is a liquid. So not all metals are solids.
Mercury is a liquid metal.
Yes, it is. So we can't put up there that metals are solids. So they're not all solids. So give me a property of metals. What have we learned this semester?
That, dang, man.
They're conductors of what? Heat and electricity. All right? So, they're good conductors of heat and electricity. Okay, they're good conductors of heat and electricity. All right, what else? Girls like to wear them for this reason.
Jewelry.
Why do we wear them as pieces of jewelry? Why are they pretty? They're shiny. What's the science word for shiny?
They have good reflection.
They're lustrous or luster. Okay, it means shiny.
I said luster.
Okay, luster. And they have good luster or lustrous. They're shiny. All right.
I truly don't know how that's I seen you write L-U and I was like luster.
Let's just be thankful. All right, now the last two are vocabulary words you might or might not have seen before. I would hope you have, but I never know. Malleable. Have you ever heard that word?
No.
Okay. It means it can be rolled. Let me get my L's to work here. Into sheets. Like aluminum foil. Any of y'all have aluminum foil at home?
Yeah.
Okay. Aluminum foil is very malleable. It can be rolled out flat into a sheet. All right. The last one is ductile. It can be drawn into wires. Okay, so if I look at Bree's lovely hoops that she's got on today, whatever that metal is that those hoops are made of are very ductile. If that metal was not ductile, could that hoop earring be made? No. Okay? Notes are not even close to being over. If you really got to go to the bathroom, you just got to go. You have any hall passes remain?
Yeah.
Then you're just going to have to go and use one. But today I'll be talking a lot.
Wait.
This is your last one, Nathaniel.
Right.
All right. All right. I think that's all I want to add to there for right now. All right, non-metals. How do they compare to that?
They're not all that.
Okay, they're not all that. So how do they compare?
But,
They're not shiny, so we'll go with dull. Okay, that's the opposite of lustrous.
They're bad conductors.
All right, so what are they good at being if they're bad conductors? What's the word we learned? All right, they're good insulators. All right, are they malleable and ductile? Could they be
No.
rolled out into sheets or drawn into wires?
No.
Okay, so what we can hit these and flatten them, right?
You got
So what would happen to them if we hit them with something? They'll break. So what's a science word we could use that's breakable? Okay, fragile is a good word. But we use a different word in science class. It starts with a B. Think what's a candy y'all would like? Butterfingers, maybe. What happens when you bite into Butterfingers?
They're brittle.
They're brittle. Okay? Brittle. Okay? I was thinking peanut brittle, but I was like, no, that gives you the word. What else could we say there? Now, here when you talk about states, the thing that makes nonmetals significantly different than metals is these have all three states. As opposed to metals, which has predominantly solids, there is one liquid, but nonmetals have all three states. All right, now the metalloids are unique because these are referred to as semi-metals.
They could be metals, but they also could be.
Okay, these are called semi-metals. these predominantly act like metals. All right, their properties vary with temperature. Okay, they're considered semi-metals. Their properties vary with temperature. Now, the most unique thing about metalloids that makes them very useful to us is their most useful one is silicon. All right, which is used in computer chips. Without the use of silicon, we would not have the technology we have today, which might be a good thing for education in the sense that teachers would not battle the use of cell phones in class. But it would also, we would not have smart boards, computers, and the other cool gadgets that we have in class also. So we'd still be teaching with chalkboards and chalk. Those of you who remember, you might have seen overheads back in the day when you started. We'd still be using those to teach class. So,
I hate chalkboards.
Huh?
I hate chalkboards.
I taught within the first 16 years I taught.
My teacher had a chalkboard.
I never had that issue.
I don't
Alright.
nails on the chalkboard before.
My old teacher had a.
All right, does everybody have what they need? Can I what?
I had to get it wrong.
Okay. Now, the biggest thing we have to do with the periodic table today is to learn about reactivity. All right, outer shell electrons and reactivity. And again, we have lost 7 instructional days, so I'm sort of, at this point, hopscotching through what I think are the most important topics. So I've trimmed what I would normally do in this section. Hopefully, I'm trimming to what I think is the most important. Truthfully, I've got no idea because I don't ever get to see the test. So, what determines the properties of all of the elements on the periodic table? For example, we put helium in balloons. We used to put hydrogen in balloons. If you've taken American history, maybe your teacher told you about the Hindenburg. The Hindenburg was a blimp, and it exploded. We used hydrogen gas in the blimp. It exploded, caught on fire, okay? We don't use hydrogen gas in blimps. We don't use hydrogen gas in balloons because hydrogen gas is very flammable. However, helium gas is not. But hydrogen gas is much more readily available, so it would be a great gas for us to use. It's less dense, it floats, but we can't use it. All right, let's just say that Jacob wants to send balloons to his mom, but let's just say she's a smoker. That'd be a problem, wouldn't it? She lights up a cigarette, balloons are close by, and kabam! All right, it's a problem. She can burn the entire house down. So, we cannot send balloons with flammable gases in it to people. So, what determines whether a gas is explosive and flammable or whether it's perfectly safe to be around? Outer shell electrons or valence electrons determine whether something's safe or not. So, we're not doing that. Not even writing that down. All right. Does everybody have what we need? All right. You still writing? Give me a wait. So we're going to talk about how outer shell electrons determines reactivity today. That's what we're going to finish with on the periodic table. And then we'll just pray we've got enough stuff about the periodic table learned. All right. So I need you to draw that. I need you to draw it pretty big, okay? Not teeny tiny, okay? Like the full width of your paper. It doesn't have to be really tall, just wide, okay? Because we're going to write stuff in each of the boxes.
So I need to draw this.
I would draw this one.
Can I get one of these?
Yes, you can. Okay, it doesn't have to be really tall. It just needs to be wide.
I got you.
Oh, crap. I sent that boy to the bathroom. I completely forgot to send you to the bathroom.
I know, yeah, they're sure kind of trying to block me, so I went the other way. I had kids.
I forget when it's a code yellow.
I had to go bad.
Go ahead.
Evan, why are you here? Oh, you're in detention. Let me mark you off my list. So you get your bathroom privilege back.
How do you use the ruler?
Huh?
How do you use the ruler?
You know, just freehand.
I
It's a quick
can't.
sketch.
I can't. I suck at drawing. Ask me.
Dude, I'm not giving you time to draw all this with rule. You're just little boxes. So do it fast. How we doing? Think? Oh, we should get a report on how we did. All right, we had time to draw. All right, so yesterday we labeled group numbers and outer shell electrons, right? So I'm going to write the group numbers at the top. So this is group number what? Group number what? Group number what? 13. Okay? Now, remember, 3 through 12 is down here in the transition elements. That's group 13. This is group what? 14, 15, 16, 17, and 18. All right, so how many outer shell electrons or valence electrons did we say were in group number 1? And group number 2? And group number 13? And group number 14? And group number 15? And group number 16? And group number 17? All right. Everybody got it? All right. I want you, not yell it out, I want you to find for me the number of outer shell electrons in each of those elements. So when I call on you, you can tell me. Okay? So if we do aluminum, for example, together. So which group is aluminum in?
13.
All right, so you got to look up aluminum. So aluminum is where? So aluminum would be here, which is in group what?
13.
Group 13. Everybody with William? It's in group 13. So if aluminum is here, aluminum has how many electrons in its outer shell?
3, right?
It has 3. Everybody got it? Okay. I want you to do the rest real quick. Because we're going to do something else with this in a minute. So you do the remaining 5 quickly. so if I ask about S, how many outer shell electrons? Oh, I don't know. And I talked to Dave Roy. How many would S have? Yes. How many would nitrogen have? Five. How many would potassium have? Alexis, I'm talking to you. Oh, that's good. Virginia, I didn't talk to you. Okay.
One?
Yes. And CL. Yeah, else I'm going to talk to. How about charisma?
7.
7 is good. How about argon? Chase. Still right. How about Sierra? AR. AR. It's all the way on the far right. By your thumb. 8. All right. Everybody good with that?
Yeah.
All right. So now, how do we determine the outer shell? How does outer shell electrons determine reactivity? Okay. Write this below your chart. Coming back to that chart, we'll write it on the back side if you're like Jacob Philip on the page. All right. We're coming back to that chart. We'll put more stuff in it. Don't feel like you drew it for nothing. I just have it further through my slides. All right. So, how many electrons do all elements want? They want 8. Okay. Tells us that this before. All right. Some of y'all just want to get out of physical science. Maybe some of y'all want to get married. You want kids. You want a college education. Everybody has a goal in life. Atoms are very limited. They only want 8 electrons. Okay. They're very singular in their goals. They want 8 electrons. That's all they want. Okay. 8 electrons. So, elements can do 2 things. Well, actually 3 things. They can lose or gain electrons to form a bond to get 8 electrons. That's why I said Friday we were going to start talking about bonding. Okay? So we're leading to get to bonding on Friday. So, we can either lose or gain electrons to get to that magic number of 8. So we need to talk a little bit about how we get to 8. Now the question is, how in-depth do you want me to go to talk about how we get to that magic number of 8? I can give you the highlights, or I can do the in-depth explanation. I'm going to do one in-depth explanation, and then I'm just going to give you the highlights. Okay? So, elements can either lose or gain electrons to get to 8. Some elements lose, some elements gain. We're going to put this on that periodic table. I got you, Edwin. That doesn't mean you need to go today, by the way. You can save that 10 minutes. All right, does everybody have it? All right, so this is the one I'm going to explain in depth. So I'm going to use sodium, okay? How do elements lose or gain electrons to get to a magic number of 8? Now, some of y'all had sodium. I don't remember who had it, but I'm going to draw a Bohr model. So whoever had sodium, how many electrons could go on that first ring? Do y'all remember? Have 2. Okay? So 2 electrons. How many could go on the second ring? So I'm going to draw 2. Up here, 2 here, 2 here, and 2 here. So we can see it's 8 a little easier because I drew them in pairs to give us 8. All right, so that gives me 10, and it can only have 11. So if that's 10 and I can only have 11, how many do I need on my third ring? I only need 1. All right, so here's my 11 electrons. Now, we said that all atoms want how many? Okay, all atoms want 8. Okay, so sodium has a choice. All right, it can gain 7 more electrons, or it can lose 1 electron. So the question is, what's easier for the sodium atom? Is it easier for it to go up to another atom and say, I need to gain 7 more electrons? Or is it easier to say, here, take my 1 electron and give it to somebody else? What would be easier for that atom to do? It is much easier to give 1 electron away than it is to gain 7 more. Think about it. John has $1. Is it easier for John to give $1 away at lunch, or is it easier for John to collect $7 more at lunch? It's much easier to give $1 away. Same thing for this atom. It is much easier for it to give 1 electron away than it is to gain 7 more, right? So it's going to choose to give away. Whoops, that's not what I meant to mark out. It's going to choose to lose 1 electron, not gain 7 more. So how does it get to that magic number of 8 if it loses 1? Well, if it loses 1, now it has this nucleus. Now, how many are on that inside ring? Still has 2, right? And now, the new outer shell has how many? It has 8. So the new outer shell has 8 electrons. Does that make sense? So when I lose this outer shell that has 1, my new outer shell now has how many? I now have 8. Okay? Yes. But when it bonds with somebody, it's going to be neutral because it's going to give it to somebody else and it'll be even. We're going to talk about that on Friday. It'll actually, but the actual evenness of it will actually be after Christmas. Okay? So, I don't need all that. Let's talk about that. All right. Back to where I was. There's where I want to be. All right. So, what did we say group 1 was going to do? If it has 1 electron in the outer shell, what's it going to do? It's going to lose 1 electron. All right. Now, in group 2, it has 2 electrons in its outer shell. What's it going to do if it's got 2 electrons? It can lose 2, or it would have to gain how many to get to 8? Lose 2 or gain 6. What would be easier, losing 2 or gaining 6? Okay, so it's going to lose 2 electrons. All right, so when we get over here to group 13, it's got 3. Again, we got to get to 8. So you got 3 in your outer shell. Lose 3 or gain 5? What's easier? Lose 3. Now, what happens when you get to 4? Well, are we going to gain 4 or lose 4? Does it matter? No. So we're going to write lose or gain 4. You can do either one. Now, that's the halfway point. At this point, we've gotten to 4 electrons. So now what's going to happen? You're going to gain. So we already have 5 electrons in the outer shell. So now we're not going to lose anymore. We've got 5. Is it easier to lose 5 or gain 3 more? We're going to gain 3. In group 16, we're going to gain 2. In group 17, we're going to gain 1. And in group 18, we're going to do what? Nothing. We already have how many electrons? 8. So in group 18, we will not lose or gain. Because it already has the magic number. Helium has only 2. It's in group 18 because it's got what we call a full outer shell. It doesn't matter that it doesn't have 8. If you take the chemistry class, we go through that there, but we're not going to do it in here. Now, how does this affect reactivity? Okay? Who would be the most stable? Who is absolutely not going to react with anybody because it's completely happy?
18.
Group 18. Okay? So, these are stable. They do not react. Okay? Group 18 has 8 electrons. They don't want to react with the soul. They have exactly the number of electrons they want. They will not form compounds. They don't lose electrons. They don't gain electrons. They have no reactivity at all. They are perfectly happy. Okay? They're not looking for a mate. Now, everybody else on the periodic table is not happy. They do not have 8 electrons. Now, their reactivity is different though. Some of them are more happy than others. Some of them are downright agitated because they do not have what they want. Okay? Now, we're going to refer to 2 of them as the hoes.
1 and 2. 1 and 2.
Okay? Well, 2 of them up there are desperate. They are desperate up there because they need some electrons bad. Okay? Bad. They're desperate. Who are my desperate people up here?
1 and 2.
All right, 1 is correct. 2 is not. All right?
What?
Number 1 are our most reactive
Oh, it's 17.
metals. Now, they're our most reactive metals because they are 1 electron away from 8. I'm going to give you a new vocabulary word. We're going to say octet. Octet is a fancy science word for 8. Okay? So, all it has to do is give away that 1 electron. It will give that electron literally to any element on the periodic table that is willing to take it. It is not selective. It is not picky. Okay? Now, if group 1 is that desperate, group 17 is equally desperate. The only thing we have to do is change the word from most reactive metals to most reactive what? They're on the non-metal side. Because remember, these are most reactive non-metals. Okay, so if I change my color here for a second, we find, all right, let me change that. Okay, put my stairs in. Over on the right-hand side are non-metals. So group 17 are non-metals. So those are the most reactive non-metals. All right, so these are going to be the most reactive non-metals because, again, they're 1 electron away from 8. Where group 1 needs to lose an electron, group 17 needs to do what? Gain 1. So they're the most reactive groups on the periodic table.
They perfectly match.
They do. And the nice part about them is when they come together, they make very stable compounds like salt. Okay? Now, who would be the next most reactive groups?
2
and 16. So we label these as moderately.
3 and 15.
All right, these are moderately reactive. Now, these that you're labeling like 13 and 15, we usually call these fairly, meaning they're pretty stable. For example, the gas that's in here that we're breathing is which?
Oxygen.
Oxygen, but most of it is what?
Carbon.
That's pencil. Remember, carbon dioxide is a compound. It's not an element. What's 78% of all the air that's in the room? Y'all took Earth science. What is 78% of all the air in this room? Nitrogen. Okay? It's nitrogen. Guys, if y'all don't stop telling me carbon is a gas, carbon is a pencil. Okay? Y'all keep telling me it's lead, and I keep telling you it's not. Okay? Everybody in this room who's writing with a pencil is writing with carbon. Is carbon a gas?
Yeah.
No, y'all are not writing with a gas. Okay? It's a black solid. That is carbon. It is not lead. Okay? That's the first thing. The black solid is not lead. So, the air in this room is nitrogen. Did I have to worry about using any kind of chemicals in here in my chemistry class?
No.
Because it was dangerous. No, that's why I said it's fairly reactive, meaning pretty stable. It's not something we have to worry about. I could use aluminum foil on my grill. I don't have to worry about it getting
Blowing
up or, charring something or causing any kind of meltdowns on my barbecue grill. Now, if I needed to react in chemistry class, I can do that. But it's not something that's going to be an issue. Okay? But if I had chlorine gas, which is in group 17, chlorine gas, a little bit of it here, if I let it loose in the room, would asphyxiate all of us within minutes.
Yeah.
Okay? It would be bad. Okay? Sodium, which is in group 1, sodium explodes in water. Okay? There's no moisture in the room that it would explode and cause a bomb. Okay? We can't even have that.
Explodes in water.
Explodes in water. Has to be stored in like kerosene or in mineral oil. It cannot be exposed to the atmosphere, it's so reactive. Okay? I can't have it at the high school level. Universities can have sodium, but I can't. Okay? Yes. No. I made a mistake sending it to him.
I'm gonna pee on myself.
Can't send you a go yellow.
Will.
Oh, my bad.
Will.
You only got to make it 6 minutes. All right. All right. We're going to let you out of the room first.
Everybody let Bree out the room.
Bree's going to be at the door when the bell rings.
She's the only person to be screaming.
That's right. We're going to let you stand at the door with your stuff all packed up. What is wrong with you?
It's me. What is it wrong with me?
Well, I wasn't going to say that.
There's a lot wrong with me. Exactly. So what is it wrong with me? Every person.
No, it's every person.
Every person here.
All right. We're going to finish this tomorrow, but we're going to start it today. All right.
What?
So, we want to determine the reactivity of those elements. But I find it helps if I make you give me a little more information first. So, if I ask you to tell me about potassium, all right. What is the group number for potassium? Okay. Everybody here? Zai's answer? Say group 1. How many outer shell electrons does it have? So, what would its reactivity be? Would it be very reactive, moderately reactive, or fairly active?
Very.
You would put very. Okay? Now, why are y'all packing up? I still got time. I want you to do those 3 before you leave. We have 4 minutes. I want you to do those 3. It shouldn't be hard. You got the table right in front of you. Your answers are literally right in front of you unless you already put it away.
Right in your face. Okay.
Write it down. Don't tell me, write it down.
I don't like that. I'll tell myself.
You're in school, you have to write.
I know. He didn't make me come to school. He ain't got me right. I know it's a secret I want to do. He can't make me right.
Said I have to come to school.
Come on, hurry up. Find me some answers. Bree should be the only one backing up. Bree, back up. You can be the door.
That's just sad. That's like not even cool. That's just sad. I fought him over that. When's your birthday? Shut up. Shut up.
That's how it comes, Dad.
Got it. Got you. Sit down. Here. Alright. So the first one. Romy, what group are we in? John. What group are we in? Fernandez. For Romy. Never mind. Alexa. What? How many electrons?
Oh, I know.
No. Electrons. 7. So what's the reactivity? Very reactive. All right, for argon, what group are we in? Krista? 18. How many electrons? Aunt Lucia? 8. What's the reactivity, Nathaniel? Janiah? For argon, what's the reactivity, Vince? For argon. It's what?
Oh, that's my favorite game.
It's what? Stable. All right, so argon is stable. For aluminum, what group are we in, Sarah? You can stay at lunch to tell me. You didn't get your stuff out. We're going over the answers. All right, Raul, what group are we in for aluminum? Apparently, you'll be staying with Sierra. The only one who should be packed up is Bree. Zaya. 13, how many electrons? Virginia. 3. So what's the reactivity? You gonna redeem yourself, Sierra? The reactivity. Aluminum. Same question. Is that group 13, 3 electrons? What's the reactivity?
No.
Is what? Nope. So what's the reactivity to loses 3? Is it very reactive, very not? It's fairly reactive. All right, you guys have to be able to tell me that. What's your homework tonight?
Study.
For the quiz on the periodic table. It is not multiple choice. I'm missing one calculator. Who's got the calculator? All right, put it up over there. The only person who should be out of their chair is who? And the person put on the calculator. Everybody else should be in the chair. Get out Bree's way. I hope they said we could go to lunch because y'all are going.
Okay, can I get my phone? I turn it off.
Say what?
Can I get my phone and turn it off?
Yes.
Well, I gotta get my game and finish my phone.